obviously there's no constant growth here, right? It's just given free cash flows. Then, we're seeing free cash flow grows at a constant rate of 5% after year 3. Okay, so if we didn't have these, negative 10 million, 20 million, 25 million, and the constant growth started at year 1, it would be very easy, like in the previous example, we can find the value of operations. This is more involved, right? Because if you remember what we said with, I think we did with bonds, right? But let's say for now. If we want to find the value of corporation, remember, we are finding the present value of the free cash flows discounted the weighted average cost of capital. So can anyone give me an idea of how you would find, just conceptually, not mathematically, conceptually, how would you find the value of the corporation given this information? How would you approach it?
So it's every year, like it's before, like there's a growth of the free cash flow.
Yeah.
And then so basically you take that, and then it would be divided by the
Excellent.
WACC,
Right.
and then it would be added.
WACC minus
Or no, not added, minus the minus 1.
minus the growth rate. Remember
Ah.
that was the formula. Free cash flow over weighted average cost of capital minus the growth rate. But that will only apply when the constant growth is in effect. So think about this. We can find the value of the corporation after we find the value of these 3. Okay, so once we find the value of the corporation, that's going to be known as something called a horizon value or a terminal value. We'll find the value of the corporation at year 3 by looking at the constant growth. But keep in mind, can we use that value at year 3 to find the value of the corporation? Do we have to do something with that value? We have to also discount that value back to time 0. Because the value of corporation is the present value of all free cash flows. If we use the constant growth model to find the value of the corporation at time 3, which is year 3, we cannot use that value. We now have to discount that value to time 0. Does that make sense? So think of it this way. Year 1's free cash flow, this has to be discounted to time 0 by 1. Year 2's free cash flow, the 20 million, this has to be discounted 2 years to present value. Free cash flow year 3, 35, has to be discounted 3 years, right? What are you discounting it by? Anyone? What are you discounting each of these free cash flows by?
10%.
10%? Why 10%?
I thought that was.
Isn't it?
Well, it could be 10%, but
Well, year 1 is 0, and then the next one is. I want to.
But you have to have the.
so here, let me
It's
show you as an example.
it should be 5, right? It's this. The year 2 should be 5, and then year 3 should be 10.
I'm keeping this conceptual, so I'm not trying to get into numbers. I'm just trying to show conceptually what it is. All right, so we are saying that this is the value of the corporation, right? Or the value of operations, okay? Right, at times 0. Okay, so we have time year 1, year 2, year 3, okay? What I'm trying to get you to understand is we have our negative 10 million, okay? We have our 20 million, and we have our 35 million, okay? If we want to find the present value of each of these sequences, we are discounting the 10 million by 1 period at the weighted average cost of capital. We are discounting the 20 million, not 1, but 2 periods at the weighted average cost of capital. And then we're discounting the 35 million by 3 periods. Okay, so now you found the present value of those 3 cash flows. Everyone with me? What is missing? What is missing in finding the full value of operations? Am I done? If I find the present value of the 35 million, the present value of the 20 million, and the present value of the negative 10 million, am I done?
No.
Why?
You see, we had the minus. The problem before that, it was 11% minus the 5%.
You good. I'm trying to keep it conceptual, but let me just go to the.
I'm probably making it difficult.
All right. So you need to understand
And that
that.
says the weighted average cost is 11%.
Yeah.
So that means.
Okay. So we have also something called horizon value. Okay. Remember what I said? After year 3, there's a constant growth, right? Constant growth of 5%, right?
Mm-hmm.
So if we want to find the present value of a constant growth free cash flow, we already did that. We said that was going to be free cash flow over weighted average cost of capital minus the growth rate, right? Remember this formula?
Mhm.
Free cash flow. Obviously, we're not taking at year 1, right? Because these are all, what would be our number here? Free cash flow at what time?
0.
No, remember, we're finding the value.
Minus 10 million, right?
What?
You said 1?
Constant
Minus
growth-
3.
Constant growth starts at the end after year 3.
Yeah.
After year 3.
After
Gotcha.
year 3.
Okay, so it'll be 35.
No, but it should be 3. No,
Yes. Very good. Very good. Year 4.
wait.
Okay. Year 4. How do you find year 4?
Subtract
It's constant
3.
growth. Remember when I said
5%,
constant growth?
5%.
35 million plus the 5%, right?
Yes. Yes.
And you divide it over the weighted average cost of capital minus the growth rate. Okay, so now you're gonna find something that's known as horizontal value. Okay, now do we add this to the present value? Would you add these two?
You said, would you add those?
Yeah, to find the full value of the corporation, would you add the present value of these 3 numbers and the horizon value? You have to discount the horizon value as well.
So you gotta discount it?
You have to discount it 3 years to get it. So you found the value of the constant growth at this point in time, but now you need to get the horizon value discounted to the present
So
value.
you're going to
Now you
opposite.
have all present values. So we'll see that with an example. So you're gonna get the present value of each of the 3 years that do not have a fixed growth rate. You find the present value. Then you find the horizon value for the constant growth rate, right? So you find your horizon value, but that horizon value is the present value at the end of year 3. It's not the present value at time equals 0. So you have to discount that by 3 to get the present value. So we'll go through an example here. All right, so
Wait, is the horizon value, is that year 3 or year 4?
it's year 3, but remember the value of operations. Remember this formula. Is that equal to
Right.
1 weighted average cost of capital minus G. So in this case, value of operations at year 3 is equal to the free cash flow at year 4 over the weighted average cost of capital. You get it? It's equivalent, just you're at a
Okay.
different point in time. All right, so I want to show you via Excel, okay? So year 1, we said it's negative 10 million, right? Everyone with me?
Mm-hmm.
Okay,
Do you have a spreadsheet?
I'm sorry?
This spreadsheet?
This I haven't uploaded, I'll upload it after. Okay, so you have negative 10 million year 1, positive 20 million year 2, positive 35 million year 3, right? These are the 3 sequences I gave you. But now we have to find the present value. Remember what the formula is for present value?
Equal minus PV.
Right. So equals present value and you fill in the parameters. We know our weighted average cost of capital is 11%, right? We know our our number of years is 1 year that we have to discount it for. Our payments are 0 and the future value is negative 10. Everyone with me? We're finding the present value of each of those sequences of monies. For the present value of 20 million, same thing. We do equals present value. We get our rate, which is the weighted average cost of capital of 11%. Our number of periods is now 2. We have 0 payments, and we have a future value of the 20 million. Okay? If you want to find the present value of the year 3 free cash flow, again, 11% is our weighted average cost of capital. Our number of periods is now 3 years. Our payments are 0 because it's not happening every year, it's only the end, future value. The future value is 35 million. With me? So we're discounting, finding the present value of each of those free cash flows at the end of year 1, end of year 2, at the end of year 3, and the full present value of those three cash flows is 32.8 million. Okay? With me? Jimmy, you with me or?
Until
So
lost somewhere.
don't get too hung up on this. What I'm trying to say is exactly what we did here. Remember we said that we're gonna get the end of year one, it's gonna be a negative $10 million. We know we have to discount this by one period to get to the present value, right? So that is exactly what the formula does. It takes the negative 10 million, discounted by the weighted average cost of capital. Remember, we're not contemplating the growth rate because the growth rate is only for constant growth. We're not discounted by the growth because the growth only applies to the horizon value. This is only being discounted by the weighted average cost of capital. Okay?
Mhm.
So.
So this VOP that
Value of
you
operations.
value of operations is only going up by the weight of costed value, like you said. It's only going. It's not. You're not adding the constant growth to it.
No, the constant growth, so this formula is only used on the constant growth to find a value.
Horizontal value.
Usually that value is not at the time zero. It's usually gonna be like when the growth is assumed to start.
Yeah.
But once you find your horizon value, you're gonna discount that by
To
the
get
weighted average
back.
cost of capital to get to the value of operations.
Can you go back through the
Yeah.
procedure again?
Here. So, end of year one, you have a free cash flow, negative 10 million.
Right.
Okay? You need to discount that by the weighted average cost of capital by one period to get to the present value.
So it's equal minus PV,
Right.
parentheses, negative 10, right?
No, you have to fill in the parameters. Remember the rate, the number of periods, the payment, and the future value.
So the rate was,
The rate is the weighted average cost of capital, which is 11%.
right,
Okay? The number of periods is obviously one, because at the end of year one, you're discounting it by 1 year.
comma. Then it's asking for a payment
Payment is none, because there's no payments in between, it's just the future value.
to a zero.
Right, 0. And then the future value, you can put in the negative,
No,
oh, in this case it would be positive, but yeah, you can put positive 10 million.
no, we need to put the positive.
Because remember, it spits it out in different directions, so if you, it's already a negative number, so you want to put
Gotcha,
it
so we'll
positive.
go positive.
So you do that, you should get 9.009.
Yep.
You got that?
Yep, now-
Alright, now you want to do the same with the year two free cash flow, which is 20 million. You put in the formula, you should get 16.232. And you do the same with the free cash flow at the end of year three of 35 million, you get to a present value of 25.592. Okay? Now, remember what I talked about the horizon value? The horizon value, if you look at the sheet here. Alright, horizon value, remember what we said? If the growth rate is less than the weighted average cost of capital, which it is in this case, and it assumes a constant growth of the free cash flow, we can use this formula, right? So we know what our free cash flow at year three is. We can multiply that 1 plus the growth rate to get the free cash flow at year four. So, look at this formula, this is what we just talked about. So this is the formula. Value of operations at time 3 is equal to the free cash flow at year 4. Remember, 1 year later, we don't have the free cash flow at year 4, but we know how to derive it because there's a constant growth. We take our free cash flow at year 3 times 1 plus the growth rate. We divide it by our new formula because we have a constant growth and the growth is less than the weighted average cost of capital. We can divide it by weighted average cost of capital minus the growth rate. So you put this in. You put the year 3's free cash flow of 35 million, multiply 1 plus the growth rate of 5%, divided by the weighted average cost of capital of 11%, minus the growth rate of 5%. Now you have a horizon value of 612 million, right? 612 million. But that 612 million is not at time 0. The 612 million is at time 3. Right? Does that make sense? It's at time 3 because the constant growth didn't start until after time 3. So you found your, think of it like this, you found your present value of the constant growth but you didn't find the present value to times 0. You found the present value at time 3. So now that you have your horizon value, you have to discount that horizon value the same way you discounted the 35 million. You have to discount it by 3 at the weighted average cost of capital to get the present value.
How?
Okay? So the horizon value, you use that formula to get the horizon value at a future point in time. If you want to get the value operations, it all has to be in present time. So now you discount that horizon value by the amount of years to get to that present value. So what are you going to have to do to that 612? What's the formula? What do you do with the 612 million?
You have to subtract from the weighted.
200 million minus.
No, we're not there yet. We're trying to find the present value of the horizon value. How do we do that?
You gotta subtract it from the weighted, the WACC.
Exactly. You not subtract it, but you would. Right? When I cost of capital, right? That's how you would do it. You have to discount it. 1 plus the weighted average cost of capital to the power of 3. The same way we did it for the 35 million. There's no difference. Okay, so we found the terminal value. Now let's go back to the Excel. So our horizon value, also known as terminal value. So if the problem gives you terminal value or horizon value, know what that is. It's not the present value at time 0. It's the present value at whatever time the constant growth starts. So our horizon value is 612, but that's not our present value. What's our present value? We put it in the formula again, right? So we know weighted average cost of capital is 11%. We know our number of periods is 3. We know our payments is 0, and we know our future value is 612 million. So we found the present value of the horizon value. So you add them all up, you get to a full value of operations of 480 million. Sabrina, you understand?
I can see.
Oh, just one more time, real quick.
Yeah.
I'm confused on the horizon.
Okay. So before in the previous problem, let me go to the previous problem.
Now,
When we found our 420 million, right?
Mm-hmm.
It was easy because we assumed that the growth rate started immediately. So the horizon value was in fact your present value because the growth started immediately. Okay, so we use this formula, right? The formula for the horizon value is basically your current free cash flow multiplied by 1 plus the growth rate over the weighted average cost of capital minus the growth rate. Okay, that's the formula. The only difference now is that your horizon value or the constant growth doesn't start immediately. It starts 3 years from now. Okay? If it starts 3 years from now, you're not finding the value at time 0, you're finding the horizon value at time 3. So once you find your horizon value at time 3, if you want to find the present value, all you have to do is discount that one number by 3 periods and get the present value. So you're doing two calculations. You're finding horizon value, you're finding the horizon value, and then you're finding the present value on the horizon value.
So you're finding the present value and you're finding the horizon value on the present value.
No, you're finding the horizon value, which is the value of the constant growth dividends,
Yeah.
and then the horizon value you need to find the present value on that horizon value to get to the value of operations.
Oh.
Okay, so again, you have to think of it like you have 4 streams of cash flow. Okay, 4 streams of cash flow. First one is the negative 10 million at the end of year 1. The second one is the 20 million at the end of year 2. The third one is the 35 million at the end of year 3. Think of the fourth one as just a cash flow. That cash flow, think of it as the horizon value, because what the horizon value is, think of it like a cash flow that accounts for all the cash flows to happen after the year 3, because it's a constant growth. Okay, so you're coming up with the cash flow. So you come up with the cash flow, now you have 4. You have the negative 10 million, you have the 20 million, you have the 35 million, and you also have in this case the 612 million. Okay, 612 again represents all the cash flows that go out to infinity. Okay, so you have 4 cash flows. Now what you're gonna do?
So you basically forecasting.
It's a forecast
Right.
but you're putting it at a semi-present time. It's not at time zero, it's when that growth became constant.
Continuously.
Exactly. Or, but stayed constant, that's the important part.
Okay.
So you have 4 cash flows, you have to now discount 2 times 0. There's nothing more than discounting negative 10 by 1 period, 20 million by 2 periods, 35 million by 3 periods, and your horizon value is 612 million by 3 periods.
About 4 periods?
3. It's 3 because, remember what I said with this formula? He brought up the same question. Value operation at time 0 is your free cash flow at time 1 over the weighted average cost. So think of it, if this is year 4, this is value operation at year 3. It's 1 year before. Okay, that's how the formula works. That's how it has to be interpreted. So, here, let's look at it with. So if you go to Excel, again, we have our negative 10 million, we have our 20 million, we have our 35 million.
Right.
Okay, now, horizon value, as I said, horizon value, you can use a different formula now to value all the free cash flows after year 3. Okay, you have free cash flows in year 4, year 5, year 6, year 7, year 8, year 9, all the way, whatever, infinity. You're not gonna wanna do a calculation for each of those free cash flows. There's a much easier formula. It's a formula that says, you know what? Use this formula to encompass all free cash flows once the constant growth starts. So that includes everything after year 3. Okay?
So the formula would be.
So that formula is that special formula that I mentioned, which is this one.
So it'd be the
Free cash flow one year from now, or in this case, year 4, over the weighted average cost of capital minus the growth rate. Okay? So once you put those numbers in the formula,
So you put the 10 million.
not 10.
Yes.
You guys are killing me. It's 35 million. Remember, we're not going back yet here.
Okay.
We are doing it for when the growth starts. The growth starts after year 3. So, you know what, let me rewrite it.
After year 3.
Right.
Okay, so.
So,
35
you know what's throwing you off is this, because this was applied when constant growth started from year
Right.
1. So now we're going to say value of operations
Right.
at t equals 3 equals free cash flow at year 4, sorry, at t equals 4 over weighted average cost of capital minus the growth rate. Okay? We don't have the free cash flow for t equals 4. How do we derive that?
You came to that conclusion. The number that you use is the 600 and.
No. How do we find what our free cash flow for year 4 is?
We take year 3. 35
Excellent,
million.
thank you, yes. So
All
that,
right,
that's equal to the
alright.
free cash flow
It's 35 million.
at t equals 3 times 1 plus the growth rate
Okay.
over weighted average cost of capital minus the growth, okay? We know what our free cash flow at t equals 3, what is it? 35 million.
All right.
35 times 1 plus, what's the growth rate? 5% over the weighted average cost of capital minus the growth
Minus
rate.
growth.
Okay, now we're getting, right, yeah, no, this is, right, 11% minus 5%. So now let's start putting into numbers, so, you know what, let me, right, I should change this to the percentages. So this is 11%
Minus 5.
minus 5%, so we have, what's 35 times 1 plus?
It'd be what, 6 times 35?
That's, two.
That's 140.
No, it's times 1 plus, should be greater than 35.
Alright.
No, I'm saying like, when you add the 1 plus 5, that would make it 6%, and then 6 plus 35, or 6 times 35 would be,
No, it's
It's
1
not
plus, it's
1%.
1.05, 1.05, that's what it is.
oh,
Don't think of it like.
Oh.
Did I remember my calculator? Let's see, so 35 times 1.05,
Yeah, calculator.
36.75. So 36.75 over 6%. Okay, so 36.75 divided by 0.06, you get to 612.5.
Yeah.
Okay, this is the horizon value. Go ahead. Yeah.
Did you do 5%? Did you do 5% times 36?
No, he did the.
No,
Or
no.
did you do the parentheses first?
No. So parentheses was supposed to represent when you do
One-
1 plus 8%.
It's 1.05.
Put this in. If it's easier for you, put it in decimal form. 5% is equivalent to what?
Okay, okay, okay.
Point
Yeah,
zero-
yeah, yeah, yeah.
0.05.
I needed all of this for the calculator, I'm
Yeah.
sorry.
So
I
you
got
would do 35 times 1.05. You get to a number of 36.75. Now you divide that by 6%, which is 0.06. You divide that 0.06, you get to 612.5 million. Okay.
Mm.
So we use the formula to find the value of those constant growth free cash flows, not at time 0, at time 3.
3.
So if we want to find the value of that at time 0, how would you do that?
Yeah, that way.
You go that way. But make it a little more. What does that mean? How do you find the time? How do you find the time out? You discount it by. So you do 612.5 million over 1 plus whack. The same way you discounted the -10, the 20, and the 35. You're going to discount that free cash flow, which is equal to the to the horizon value, right? At t equals 3. So you're going to discount that by 1 plus weighted average cost of capital to the power of 3. Okay. So think of it this way. You have, this is what our value of operation will be at time 0.
Would that be at times 3? Would that be 18%? Because you're gonna do the 11 minus. You get a lawsuit.
Well, it's 11.
Wait, no, it's 11 plus 1. 11 plus 1, right?
Yeah, it's 11%.
What's 1.1?
Sometimes you got to rely on Excel or the calculator. Don't get confused. Just know it's the power of 3. Okay. Don't try to calculate in your head. It's gonna. But if you want to find the full value of operations, okay. So think of it this way: the -10 million over 1 plus whack to the power of 1. Okay, that's going to be the present value. Okay.
Okay.
Now, if you want to find the present value of the 20 million, you're going to do
Same
20 million. No, not the same thing.
2 years, right?
To the power of 2.
2.
Okay. Now the present value
35.
of 35 is equal to 35 over 1 plus whack
3.
to the power of 3. Got it? And now for the present value of horizon value, what's our value that we're discounting?
It was what
What's the amount?
1.11?
No, 36.75, right?
612.5 million. Okay? 612.
Oh, the final.
The final.
Yeah, that's the value, yeah. 612.5 over 1 plus
11.
whack to what power?
3.
The 3 power.
Very
3 power.
So now you add them all up, and that's what I'm doing on Excel. Instead of writing it out, I'm just putting it on Excel. That's how you find the present value of each of those cash flows. So we have a present value of the 10 million at 9. We have a present value of the 20 million at 16. We have the present value of 35 at 25. We have the present value of 612 at 447. You add them all up, you get to a full value of operations at time 0.
I got it.
You got it?
I got it.
Very good. $480 million.
Oh, no, I got 447.
No, that's right. That's for the horizon value. That's correct. But now you have to add in the present value of the other 3 cash flows. Okay.
So you said you got, the answer is 0.0
No, the answer is
or 480?
480.67 million.
All right. But that answer, so the 612, that is the what the answer is
Horizontal.
all right, that's the horizontal. That's what that's
Horizontal
called.
value, which is the value of operations at t equals
3.
Not, but you need to find this at t equals 0. To find at t equals 0, you have to discount it for 3 years. You
Yes.
discount it for 3 years at the weighted average cost of capital, the same way you discounted the -10 by the weighted average cost of capital at 1 year, the 20 million the weighted average cost of capital at 2 years, 35 million weighted average cost of capital at 3 years. This is just like another number that's right here, and you have to discount it 3 years.
Yeah.
You add up all the present values, you get to the full value of operations.
Alright, Professor, but the number that you added over to the left,
Yeah,
Those values, well, I can't see from here, so, that,
yeah, so all I'm doing is discounting the negative
I
10,
know, I'm talking the actual
Yeah.
Excel spreadsheet.
480,
Up, go up.
this.
What's those numbers up top, above that?
That's the present value of the negative 10.
Which is, what's that number you have?
What do you mean?
What
Like-
number is that? I can't see.
That's negative 9.009.
I think that's what it's gonna get you.
Yeah,
All this just clicked.
it just, that's,
It just clicked just like that.
exactly. You have to just, we're finding the present value of the negative 10, one period
You
discounted.
got 9.01.
Yeah, discounted the 20 million by 2 years,
Yeah.
it's worth 16. You
Right.
discount the 35, 3 years, you get to 25.
That's
And then-
what's throwing me off, 'cause I have 812, and you saying 16, I'm like,
What is?
No,
I did
it's-
it by 2, but it's still coming out 8.212.
Let me see your formula.
Right? So 11%, 2
It's
years.
not 10 million, it's 20 million. 20.
No, but I got jumps.
Change it, let's see if you get it, 20 million.
That's what the problem. So now, what's he talking about?
20. Alright, that's your
And
16.23.
I got the same for 3.
Same, you gotta make it 35 million.
Gotcha. You know I did wrong, because what I did, I dragged it down.
Gotcha.
Now I gotta put the
Yeah,
numbers in
and
place.
change it, yeah.
That's
And
what I
then
did.
here, change it to 35. Okay, that's your 25.59.
Gotcha.
And then the last number is gonna basically be like another year 3, which is the horizon value. The horizon value, we know it's 612 million, so you put 612.5. You can put it here. Put it right here, 612.5. Okay. And drag that formula. Oh no, yes, put it here.
Right here, right?
Yeah, 612.5 there. And then you can drag the formula from the cell above here, drag it down.
You do this one. Like this one down?
No, the 25.59,
Mm-hmm.
drag it down.
Oh, okay.
Okay, so click on that. Change that to 612.5. Why is yours slightly off? Mine is 447. Click on the formula. Solving that. What percent of the full value of operations at time 0 is based off the cash flows from year 4 and beyond? What would be your way of approaching it?
You said what percent
What portion of the value of operations is due to the free cash flow that starts from year 4 and beyond?
Could you just do year 3 times the 5% and then be able to get, like, at a constant, year 3 at a
Well,
at a constant?
keep in mind, we already found
You're
the
four.
present value of all 4. So it's really, if you think about it, it's very simple. You would just take your present value of your horizon value, which was, what was it, 412? What was it?
480.
480? You take the 480 over the full value of operations. Okay, so,
So you saying take the 447 divided by 480?
no, see, it wasn't 480, it was 612.
Huh?
So the horizon value, okay,
612.5.
right,
Yeah.
but that had to be discounted, and we found it at 447, right? That was the present value, 447.
Okay.
So the present value is what we care about.
Okay.
447 over the full value of 480 is due to cash flows from year 4 and beyond. Is that clear?
That's when you find out the constant growth. That's when you
Right,
can
that's when you
go.
find your constant growth, but when we talk about the value of operations, we're talking about time 0. So when we found the horizon value and we discounted it to time 0, we know that number was 447. If we want to know what value of the corporation or the value of operations is due to cash flows from year 4 and beyond, we take that 447 over the full present value and we just calculate a percentage. So again, just to be clear,
You find out all these.
the question is, how much of the value of operations is based on the cash flows from year 4 and beyond? If you're rephrasing it, what they're trying to say is how much is the present value, right, of the free cash flow at t equals 0. They're saying what portion of that is due to t equals 4 and beyond. What they're trying to say is how much of that present value is due to the horizon value, or the present value of the horizon value, right? So
So you take the
the 440,
447.85,
right, 447.855 over the 480,
480.
right?
So it's division.
Yeah, it's division, it's just an allocation. So we can say that 93% of the value of operation is due to the cash flows at times equal 4 and beyond. Okay? This is very, very high because for the average company, this percentage is usually about 80%. Okay? Any questions on that? Is that good? All right. So one can ask, if the value of a company is really concentrated on much later in the future, why are people so concerned about quarterly reportings? If you know, the reason that is because quarterly reporting signal changes in your future cash flows. For example, like if they didn't do well this quarter, you want to find out, was it a temporary issue? Then you wouldn't care so much if it's temporary. But if it's a strategic move that you think impacts your future free cash flows, then you have to contemplate what the hell's going on. So all that needs to be considered. So changes in quarterly earnings can signal changes in future cash flows, which obviously would affect the stock price. Remember what I said? You have to be careful with managers. Sometimes you have an agency conflict, an agency problem. Because managers have a way where they try to maximize their bonus, which are tied to the quarterly earnings. Sometimes they might make decisions that would inflate the quarterly earnings, but might hurt the future cash flows of the company, which indirectly impacts the stock price. Because the stock price is based off future cash flows.
You know what the guy that did the Bitcoin, that's what he did? He inflated everything.
The Bitcoin, was it?
He went to jail. So,
Not with Bitcoin.
in crypto, crypto world.
Oh, yeah, it was the one that Tom Brady lost in. That one. But just keep in mind, so managers need to act in the interest of the stockholders, right? So you have to be careful because sometimes their interest is not aligned with that of the stockholders. They might be focused on maximizing short-term earnings at the detriment of long-term earnings. And we just saw that a stock price is mostly concentrated on long-term earnings. Okay, so that's very important to understand. All right, I think you guys, we've done a lot, but let me just, I know this chapter is very, very heavy. But all that's gonna happen later on when you're going through the slide, I need you to understand, all we're doing now is assuming growth on sales, right? And certain percentages of net operating profit after tax, operating capital, and we're gonna continue using an assumption where the growth stabilizes and it's a constant growth. But trust me, I know it's a lot, but we've covered the main points. So when you have problems in the homework that talk about what's the horizon value, what's the value of operations, you should have no problem answering them because just refer back to the type of calculation we're talking about. So again, horizon value, right? Horizon value is going to be where the growth stabilizes and it's constant, and you do that by taking the free cash flow the following year over the weighted average cost of capital minus the growth rate, right? That's going to account for all the cash flows that are constant. And then if you have cash flows before that are not constant, you have to find their individual present values like we just did. We found the individual present value of the negative 10 million. We found the individual present value of the 20, the individual present value of the 35, and then the individual present value of the horizon value. And that gives you the full value of operations at time 0.
Don't forget to put spreadsheet up.
I'll put it up. All right, just quickly on multiples. Remember we talked about multiples? Let's see. All right, so remember I gave the example of price to earnings multiple. So this is the price per share divided by the earnings per share. So you look at a comparable firm, right? Say you want to value Alibaba, and it's a relatively new firm. You only have much to base it off of, so you go to a comparable firm like Amazon. You look at what Amazon's price per share divided by the earnings per share, you get that multiple, and now you apply that multiple to the earnings per share of Alibaba to get to the price per share. And then if you want the full value of the company, you just do the price per share times the number of shares that are outstanding. Okay, so again, we estimate the average price to earnings ratio of comparable firms, in this case it will be Amazon, then we multiply that price to earnings ratio by the expected earnings of Alibaba, which is the company that we're trying to estimate stock price for. Okay, you can also do the same with the market value, you can also do with, with EBITDA, with sales, with the number of customers. So for example, if you're doing it based off EBITDA, you would look at Amazon and say, okay, the value of the company over the EBITDA, or say value of the company over the number of customers, you take that ratio and you apply it to Alibaba's number of customers or their EBITDA to get to their value. So you're just applying the same ratio for the comparable firm to the current firm, and you're looking at the EBITDA, you're looking at the number of customers, or you're looking at things like, sales, whatever the case may be. Okay. When you reach the dividend model, it's very similar, very, very similar to the free cash flow model. You're just gonna keep growing the dividends, and you find that something similar to horizon value with the dividends, you get to discount that to get to the price per stock. So you see here, very similar. You have dividend in year one. You're going to not divide it by the weighted average cost of capital. Remember I said the weighted average cost of capital is only for the company in its entirety. The dividend only focuses on the common stockholders. So when it comes to common stockholders, we're talking about the required rate of return on the stock. So you're going to take the dividends in year one, year two, year three, you're going to divide it or discount it by the required rate of return on that stock. Okay, and the same concept, how do you find the present value of an infinite stream? Right? You're allowed to use a formula. That formula is going to be, where is it? This. So to get to the price of a stock, you're going to take the dividend at year one or time one over the required rate of return minus the growth rate. So keep in mind how it differentiates from this. We're not talking about free cash flow because free cash flow pertains to the entire company. Okay, now we're only talking about the stock. So we're not talking about free cash flow, we're only talking about dividends. Okay, just dividends. We're not using weighted average cost of capital because weighted average cost of capital was for the company in its entirety. It included stockholders and debt holders. Remember, the weighted average cost of capital is the weighted average of those two returns. We're only talking about stock, so it's not going to be weighted average cost of capital. It's going to only be the required return on the stock. So that's how the formula varies. You understand that? So again, value of operations was for the company in its entirety. We looked at the free cash flow, which is available to all investors. But when we're talking about stock, we don't care about all investors. We only care about the stockholders. So that free cash flow of the stockholders is dividends, right? We're now looking at the weighted average cost of capital because the weighted average cost of capital included the blended cost of debt and the blended cost of stock, right? The required rate of stock. We're only talking about dividends. We don't care about the cost of debt. We only care about the return on stock. So you're just substituting dividends for free cash flow, and you're substituting required return on stock for weighted average cost of capital. And the formula is the exact same. You see it's the same formula. So this is how you find the horizon value, and you would just discount it by, what would you discount it by to find the present value? You use this to find the horizon value. How would you find the present value of that horizon value? How would you do it?
Whatever year you're starting at.
Whatever you're starting at, but what rate?
The growth rate.
So you don't do the 11 minus the 5?
What? Remember, the 11% was weighted average cost of capital. We don't care about
I don't know
So
what ours is.
you want to do
So
it's
it's
the
the stock. It's the stock dividend,
It's
right?
the required return on stock. So remember when we were doing, where is it? Did I delete it? Oh, here. We were doing free cash flow over 1 plus the weighted average cost of capital to the power of t, right? That's how you found the present value. You did that for each of those 4 sequences. Now we're going to do dividends over 1 plus the required return on stock to the power of t. That's how you discount it. So you're just substituting variables. The same concept. but now you have a tunnel vision. Now you're not focused on the value of the corporation in its entirety. You only want to value the stock. That's it. Okay? So that's, you get the concept, right? It's the same exact concept. You're just substituting the dividends for free cash flow and the required return on the stock instead of weighted average cost of capital. Okay? It's just more focused. That's all it is. And you'll see that here. And the same concepts apply. You need a constant growth rate in order to apply that, horizontal value formula. And growth needs to be less than the required return on stock. It's all the same exact logic. You're just substituting variables. That's it. Okay, this is another important thing. To find the required return on stock, what if it's not given? What if they don't tell you what the required return on the stock is? Remember we talked about, I think 2 classes ago, in order to find that, we can use something called the capital asset pricing model. I think you weren't here, right?
No.
Capital asset pricing model. Remember we talked about beta, we talked about market risk premium, we talked about risk-free rate. So conceptually, the required return on stock, that is basically what a stockholder requires as a return on their investment in your corporation. They're gonna want at least the risk-free rate. What is the risk-free rate? Risk-free rate is a return that you get with a riskless security. So think about it. If U.S. Treasuries are riskless, pretty much, right? You're lending money to the government, much safer than lending it to a corporation, right? So you're gonna at least expect the risk-free rate. Let's say the government is paying 7%. You're gonna want something more than 7%. So you have the risk-free rate. Now you want to look at what kind of added risk does this stock have to the corporation. So you look at the beta of the firm and the market risk premium. The market risk premium is the additional premium that you get on top of the risk-free rate
So if
because it's
7,
what the market pays.
Right, so if it's 7 and you go to 12. then-
Right, exactly. So it'll be 5% market risk premium. 5%, but you're not gonna take the full 5 because you have to look at the beta. It's
Right.
what added risk that security has. Remember, securities have different types of risk as well. You can't just say all stocks have 5% additional risk over the risk-free rate. You have to also look at the beta, what additional risk that firm has. In this case, it's 1.2. You do 7% risk-free plus market risk premium, which represents the additional rate of return you expect from stocks instead of riskless securities, multiplied by the beta. It says this stock needs at least 13%. That's how you can calculate required return on the stock. Now you can use your required return on the stock to calculate your present value of operations based off of dividends. Okay? And again, exact same logic. You'll see through the formulas, it's all the same. You're just substituting. This I do want to go over. So you can calculate. Here, let me show you. Did they have it here? Actually, no. For this one, where is it? All right. You'll see this is pretty cool. So we have a required return on the stock. We calculate as being 13%, right?
Mhm.
We know that stocks can yield in 2 different ways. Stocks can yield in the form of a dividend, and stocks can also yield in the form of appreciation in value, right? So there are some stocks that don't issue many dividends, but the value of the stock goes up. And once you sell it, you realize a big gain. So if you want to look at the allocation of that yield, you can break it out. You can calculate the dividend yield, which is the dividend over the dividend a year from now over the current price. So dividend a year from now, remember the dividend in this case was $2. That's the current dividend. If you want to find the dividend a year from now, you just do it times 1 plus the growth rate, which is 6%. So that $2 becomes $2.12. Okay, that's the dividend at t equals 1. T equals 1 is equal to t, the dividend at t equals 0 plus the growth rate. Okay, so your dividend at year t equals 1 is 2.12 over the current price, which is t equals 0 is $30.29. That gives you a dividend yield of 7%. Okay. Now, what do you think the difference is? Without even doing this math, you know that the required yield on the stock was what?
6%.
the required return on the stock was 13%. We used the capital asset
They
pricing
said
model.
the gross, right?
Yeah.
That's 6, so that way they tell you that's 7%.
7% is gonna be the growth of the
Right.
stock, correct? Because we already calculated as 6% being the dividend yield, so we know the rest has to be due to the appreciation in stock. So the appreciation in stock, you can calculate it, right? You can take the price of the stock at T equals 1 minus the price of the stock at T equals 0 over the price of the stock at T equals 0. That's how you find the change in value of the stock, okay? So you take $32.10 minus the $30.29 over the $30.29. So the value of the stock went up 6%. When you found the value at T equals 1, remember how you found that? T equals 1. Where is it? See, so keep in mind, the slide has this wrong. This should be price at T equals 1, not price at T equals 0. Price at T equals 1 is dividend 1, required return minus the growth, you get 32.1. And then the price at P equals 0 is, this formula gets to $30.29. Change is 6%. So this dividend yield 7%, capital gains yield is 6%, you add the two, and it's equal exactly the required return on the stock, which is the capital asset pricing model that we used. Okay. Same concept for non-constant growth. You would use the same approach, right? You would use each individual's dividend, you discount it by 1 over, not the weighted average cost of capital, but 1 over the required return on the stock. You can find the present value of those dividends. And then you find the present value of the horizontal value, which accounts for all the dividends once that constant growth hits. Okay? So in this case, the constant growth started after 3 years, similar to this one, right? So you would do the same exact thing. You would find the present value of each dividend in the forecast period. Then you find the present value of the horizon value. You sum up all the present values of the dividends and the horizon value, and the result is the estimated stock value. Is that clear? So when you're doing stocks, it's a little different from the full value of the operations because you're only focused on the stock. You're not going to use free cash flow, you're going to use dividends. You're not going to use weighted average cost of capital, you're going to use required return on the stock. But the concept is still the same. You have dividends in each year without a constant growth, so you're going to discount it to present value, and then you're going to have a horizon value that accounts for all the future dividends that grow at a constant rate. You're going to discount that horizontal value of those dividends to the present value, and then you have a full value of the company, or the stock, I should say. Okay? Alright, I think that's it. If you have any questions on the homework, just let me know. But, this is 90 slides, so you probably have a lot of bit of reading to do, so don't start it Friday night. Try to start as soon as possible.
Dang.